Good afternoon and good morning to those of you at West. Welcome to today's webinar for Metal Architecture and Steelscape. My name is Hannah Cole, and I'm the Associate Editor of Metal Architecture. I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We'll address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, please only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. As well, it may take up to 5 business days if you require a certificate, so keep an eye on your inbox and don't forget to check your spam and junk folders as well. Now, I'd like to introduce our speaker, Michelle Vondran. Michelle is the Product Innovation and Technology Manager for Steelscape North America. She graduated from California Polytechnic State University with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, later Bassif coil coatings, focusing on polymers. This position included lab development, lab to production, scale up, and manufacturing quality and process control. Michelle later specialized in cool pigment technology, helping bring the industry's first cool coil coatings to market and contributing to the Cool Roof Rating Council and the Energy Star Roofing Program. She joined Steelscape as a quality engineer on the Rancho Cucamonga, California paint line and went on to serve as quality systems manager and technical manager. Today, as product innovation and technology manager, she leads product and process development, performance standards, and warranty programs for the NS Blue Coated Products North America, comprised of Steelscape and ASC profiles. Michelle is an active National Coil Coaters Association board member, sitting on the technical committee, and a Zinc Aluminum Coaters Association member. In this webinar, Michelle will discuss how surface coating is the first line of defense in pre-painted metal and is one of the most important elements to consider when specifying metal roofing and siding. Selecting the right coating, finish, and paint system can affect product lifespan, energy efficiency, and aesthetic appeal. This course discusses the composition of pre-painted metal, its application, performance, and examines building and environmental factors that may influence the type of paint system specified. Michelle, we really appreciate you joining us today. Please take it away.
Thank you, Hannah. That's quite the introduction. Appreciate it. Welcome, everyone. Yeah, we're going to go over understanding pre-painted metal. We've got like 4 sections we're going to go through. We will stop at the end of each section and take some questions and then questions at the end as well. It's a very full presentation. We usually need the full hour, sometimes a little bit over. If we don't get to your questions, my information will be provided. You can reach out to me separately. So we will jump in. Presentation overview, won't bore you with that. You all know what you're here for. Here's the learning objectives today. We're going to go over the pre-painted metal fundamentals, kind of how we make this product and what it's used for. We'll do a deeper dive into types of paint systems, their differences, and why you might want to choose one versus the other. We'll talk about enhancement options for pre-painted metal, specialty stuff that's available. And then we'll talk about durability and warranties at the end. So what is pre-painted metal? Pretty self-explanatory, exactly what it says. So this is a substrate, usually coated steel or aluminum, that has been painted prior to fabrication into its final part. So it's not all the same. Got to get the right coating, the right substrate, the right visual effects, but there's lots and lots of options, which we will go over today. Our products, pre-painted products or coil-coated products, we use that term as well, is used in a wide range of applications. The focus today is exterior siding and roofing panels, construction industry, but can be used for interior, can be used for HVAC, appliances, cabinetry, hot water heaters, door trims, window trims, All of that is usually pre-painted through this process for fabrication. So how is our paint applied? The airbrush, dipping, rolling, or brushing? We use rolling, but not like the rolling you probably are used to, like rolling paint on like a house application. So these are big, long, big, continuous running industrial lines. It's so we actually, the strip, the substrate is moving and we move the rollers in onto the strip rather than moving the rolls. It's baked on. It's all solvent-based, baked on. So we are applying paint, drying it, curing it, and rewrapping that coil, usually in like 45 to 30 seconds. So it's very, very fast. All of these paint lines vary a little bit in configuration and capability, but so this is kind of a generic layout here. These lines run anywhere from 100 feet per minute up to 700 feet per minute. So like I said, very, very quick. 15 to 30 seconds to cure and dry the paint. We have two coils we can load at the entrance. We have these accumulator towers, which move up and down and allow us to control how much product is in the line so that we can run continuously. There's a cleaning section. We clean the substrate and then we put a pre-treatment on it. And then almost everything gets a primer layer. That gets baked and cured. Then it gets its top coat or finish coat. That gets cured as well. Everything gets cooled down. At the exit of the line, we're wrapping that coil back up and off it goes to be formed into whatever final part it needs to be. The advantages to this process are how tightly controlled it is, how quick it is, very consistent. We can repeat colors and film control over and over and over. It's rapid. We're only using 1.4 mils of paint total. That is thinner than a piece of paper. So it's a very, very thin coating, but we're expecting it to do a lot performance-wise, and we'll get into that later. Most other industrial coatings, painted products are 2 to 5 mils thick, so a very big difference in thickness. And again, it's painted before fabrication, so this paint has to withstand the fabrication process afterwards, as well as go on the outside of a building and hold up for 30, 40, 50 years without much weathering. So there's a lot of science from the paint companies and the coating companies that go into these products. Like I said, these are solvent-based paint systems, but all of these lines are closed-loop systems. We're burning those solvents off during manufacturing, capturing those, using that heat back into the ovens. The final product has no VOCs or anything being emitted off of it. The limitations of this, though, are that once we're running, we need to run for long periods of time. So we don't like to do small jobs. We don't like to change the paint very often if we can avoid it. So this can restrict the color palette a little bit, and it restricts the order size. We can't run just a few hundred feet of product. A lot of these paint lines hold anywhere from 1,000 to 3,000 linear feet of product from end to end. So the quantities are quite large. The quality control that we do is extensive, and it's to mimic the fabrication that's going to happen downstream. So we bend it, we bump it, we impact it, we scratch it to make sure that this paint is going to hold up. That's from a formability point of view. Color is huge, right? We need these colors that get run over and over and over to look the same visually time after time. So we're controlling color very tightly, both with computers, also visual assessments. The gloss needs to be consistent and the same from run to run, coil to coil. And the film thickness, as tiny as that film thickness is, we have to control it very tightly because it is key to the long-term performance and the warranty performance that these products are going to have. And while we're going to go deep on paint, I do want to talk about the substrate. Like I said, most of this is coated steel, so metallic coated steel product. There's two main products out there that you'll run into: galvanized, hot dip galvanized, or aluminum zinc alloy. Galvanizing is 100% zinc coating that goes over the base steel to limit corrosion. The aluminum zinc product is known by two trade names, Galvalume or Zincalume. They're the same product. That is a 55% aluminum, 45% zinc product. The addition of aluminum gives you added corrosion. So much better performance long term, especially in severe environments. That aluminum becomes very inert and doesn't allow much corrosion to take place. And that 55% is an optimal ratio that was developed 50, almost 60 years ago now. The galvalume name and the zincalume name are both registered trademarks. Um, there's a licensed company called BEIC that licensed that galvalume product. You cannot use that name unless you are licensed and are adhering to the manufacturing quality expectations of that product. So the metallic coating product process is quite dynamic as well. These are even bigger lines than the paint lines. So goes through a molten bath to get this metallic coating put on. Again, the aluminum acts as a protective barrier. The zinc portion is a sacrificial barrier out there in the field. Again, licensed. There are corrosion warranties on the Galvalume product. You will not see that on galvanized, but Galvalume is warranted in some conditions up to 60 years not to corrode through. Obviously, there's a lot of caveats around that about specific installation in the environment, but really long warranties on this product can be had. So what is paint? I think we all know what paint is. We've all experienced paint in some form in our lives. It's a liquid designed to dry to a solid surface, and it's got two functions usually. Protect the surface, make it look the way we want it to look. For our world, we deal with four primary ingredients of paint. We've got resin or polymer, that's the binder or the backbone of the paint. It's going to determine the primary physical and chemical properties of that paint system. Then you have pigments, probably the next most important. That's how it looks, how it feels, the aesthetic values it brings to the table. The solvents, that's to keep it liquid. Doesn't really matter to the end user, but matters to us as the coater. We got to be able to pump it out of a drum, and it needs to be the right viscosity and go on our rolls, and we've got to be able to clean it up well afterwards. And then there's kind of this last 5%, which are miscellaneous additives that run the gamut, controlled gloss, UV protection, flow additives. We call that kind of the magic stuff that the paint companies put in at the end. So kind of a cheat sheet. The resin or the polymer, that's that person in the group project that does all the heavy lifting and most of the work. They're bringing the most to the table here, and then pigment and then solvent. The pigments, right, are mostly aesthetic, and we're going to talk about them a little bit more in depth, but they also help with corrosion, water resistance, and the long-term durability as well. It's kind of the ratio by weight of those four items. What's the right paint, right? Like, how do you select your right paint? So it's a balance of all these properties, and the end application, the end product you're trying to achieve really will dictate which way you go. Do you need something very soft and flexible? Do you need something that's a little more hard but might not form as well? For construction products, panels, and roofing, we typically fall towards this harder side of the scale. It needs to be scratch resistant, needs to be durable in transport. While you're putting it up on a roof, right, handling it at a job site, it needs to hold up. But it needs to have some flexibility to make the final panel and form as well. So it's always a balancing act. This is why the paint companies have a wide range of product options that we can use depending on the use. Pigments and color. Again, very important. These are insoluble solid particles. They're finely dispersed and ground to a really tiny particle size so that it covers the resin or the polymer backbone in its entirety. We use two classes of pigments in this world, inorganic and organic. Inorganic are usually mined out of the ground. These are metal oxides that are then heat treated at very high heat, like 2000 plus degrees Fahrenheit, to stabilize them so that they weather really, really well. They don't fade over time. But visually, they tend to be a bit duller, right? These are your duller yellows, reds, browns, kind of mid-tones. Organic pigments are from organic sources. They're very bright, typically. These are primary colors, your bright reds, your greens, your bright yellows, and oranges. And while they're pretty, though, they don't weather very well. I think most of us can probably identify that bright colors over time tend to fade more. So we try to limit how much organic pigmentation is being used in these formulas. We allow a very small percentage, but it could limit the final visual color you're trying to achieve. If you want a super bright yellow, it may just not be possible. But they are a nice distinctive look. Talked about color control, right? The eye's perception, wavelengths of visible light reflecting off a surface. We do measure this numerically on almost everything we do. It's represented by what we call an LAB number, so light, dark, green, red, blue, yellow scale. We have a target that we're measuring to for every production run, and we control it to a difference that is less than what the human eye can actually pick up. And we talked earlier about on the line configuration. There's more than one layer of paint going on here for metal panels. So it's kind of a schematic here. You have your base steel in the middle, which is your core. You've got your metallic coating that we talked about that goes on. Then you've got a pre-treatment, which is a kind of a clear, just a treatment that helps the rest of the paint bind to that surface. And then you've got your primer layer and your top coat layer. You may or may not have a clear coat, depending on application. We do always coat both sides. So the bottom side or the back side of that substrate is also going to get coated. Same primer usually, just kind of a neutral colored backer. The reason we do this is if you wrap bare metal up in that coil form against the top coat, it's going to damage the painted surface. So we like to have both sides painted. It's also going to provide extra corrosion protection and longevity in the field as well. Okay, I'm going to stop there, I think, for any questions. You've got any yet?
Thank you so much. That was very informative. We do have a couple of questions that came in already. First of all, will a backer coat have the same life as the top coat?
Typically, no. Our standard, what we call universal backers, are applied at half as much film and are not designed to have the same weathering capabilities because most of the time that bottom side is not exposed in final installation. That said, we are capable of coating full paint systems, including different colors on the top and the bottom of the strip. So if you have an application like a screen or depending on your design where that backside is going to be exposed to the elements, you can get a full paint system that's going to have longevity on that backside. It is possible.
Oh, interesting. It's cool to see things can be tailored to the project.
Yep.
Another question that came in, how do you control the batch-to-batch color consistency? Is color consistency better with SMP or PVDF paint systems?
I don't think the consistency is different between the paint systems, but the paint companies who are making the paint have a lot of quality control, process control in place to make sure that they are consistent from batch to batch, drum of paint to drum of paint. So it starts with them and then moves through the supply chain to us, and then our process controls are really tight. So we're reading film, paint film in real time as we run. We're doing frequent checks. We have the prior production history of that color to know if it's trending the same as it always has or not. There's a lot of quality system management and process management that goes into that. And, for the most part, it's really not, knock on wood, a major issue anymore. But, the paint companies are making most of their paints anymore on fully computerized, controlled, we call dispense cells. So, they are controlling how much pigment and stuff goes in to, really tight, small weight percentages. So, it does happen, but overall color consistency's really become a non-issue, I would say, in the last 20, 25 years for our industry.
That's great to hear. And one more question before we move on to the
Okay.
next section. What color or colors tend to fade faster? Kynar or non-kynar, or is that relevant?
I would ask to hold that. We're going to get into that here
Okay.
momentarily.
In that case, feel free to move on to the next section. Thank
Okay.
you so much.
Thanks. Okay, we're going to get into paint systems and their differences because there's a lot of different paint chemistries available. So, what are the three common paint systems used in building applications? It's polyester, silicone modified polyester, SMP for short, fluorocarbon or PVDF, also known as Kynar. So we're going to dig into each one of these a bit, explain the differences, and when you might want to use one over the other. I apologize. I don't know why, as an industry for the fluorocarbons, we decided we needed about 5 different names for that. I think someone just wanted to confuse everyone, but we do use fluorocarbon, PVDF, polyvinylidene fluoride. That's a chemical name. There will not be a test on that later, I promise you. Also known as Kynar 500 and Hylar 5000. So we have a lot of different names for that one group of paint. These are kind of listed in the typical good to best, right? Your polyesters are good. Silicone polyesters might be a bit better. And then your fluorocarbons are kind of float to the top as being the best performers. I am obligated to indicate to those who don't know, Kynar 500 and Hylar 5000, those are registered trademark resin products. You cannot use those names unless you are licensed to use that product in your paint system. So oftentimes if you see someone saying, oh, we have a PVDF, and they're not using the Kynar or the Hylar name, it means they don't have a license through those two suppliers. So polyesters are the workhorse of our world. Hugely diverse in what you can do with formulation. And I always like to use the example, you're already familiar with polyesters, maybe not as a paint, but I'm sure many of us on this call are wearing polyester clothing. So polyester, the ester group in the chemical world, I'm going to do a little tiny bit of chemistry with you guys. Esters are hugely variable. So you can make everything from clothing to hard plastics to these liquid paints using that type of chemistry, depending on how you put it together. So a lot going on though. They're very cost effective. Our polyester paints tend to have really good flexibility and hardness. They're available in a wide range of colors and glosses, everything from very low gloss to very, very high gloss. Some of the other paint systems can't achieve that very high gloss look. Have to use a polyester for that. So you actually see polyesters getting used a lot like in appliance coatings that have that high gloss finish. If you think about your ovens and refrigerators and washers and dryers, that's probably all polyester technology. So very versatile. In the buildings world, we see it used a lot in what we would say lower end ag and commercial roof and walls. It's used extensively in gutters, downspouts, rainwater as well. I have to add a caveat here, and I probably need to update my presentation. There are now what we call super polyesters or super durable polyester technology that has come online in the last 5 or 10 years, whose performance is very, very high and is rivaling PVDF. We're going to talk about that. So I always caution people with talking about polyesters because there's everything from very low end, you're not going to get any warranty or long-term performance polyesters, to really, really great, outstanding, super high performing polyesters that are going to come with 30, 35-year warranties. So you got to be careful in the polyester space because they're not all the same. Oops, I went back. Sorry about that. Silicone modified polyesters introduced about maybe 30 years ago now. This is a polyester that's had silicone reacted into that polymer backbone. And when you do that, if you do it right and in the right percentage, you get kind of a step up in exterior weatherability, improved resistance to chalk and fade. You still get the wide range of colors that's available in polyesters, and it's a little bit lower cost point than the PVDF and the Kynar system. So SMPs here in the United States have been very, very popular now for a long time. In light commercial and residential, we see a lot of residential roofing and sidewalls using SMPs because you get that step up in performance without having to spend the money for a PVDF. And then there's the fluorocarbons, PVDF, Kynars. This is like kind of the Cadillac paint system here in the US. They have incredible resistance to fading and chalk on exposure. They have really good chemical resistance as well and great formability. And that chemical resistance is important because if you're in an industrial or a heavy corrosive environment, this is kind of the paint system you need to go to. So we're talking about that a little bit more later, but marine settings next to the ocean that are more corrosive. The PVDF or the fluorocarbons are going to be your go-to for those. We see this used extensively in big architectural commercial projects. Do see it in residential as well, but not as much. PVDF Kynar 500 is written into the Corps of Engineering specs. It's written in most big architectural specs. Almost any big high rise you see with painted metal on it is going to be PVDF. Comes with a cost, high performance. Get what you pay for. It's kind of, again, top of the line. Again, a little cheat sheet here on the polyesters, SMPs, and PVDS. Polyester is getting good to better. I would say, the right way to phrase this, the performance differential between polyesters and SMPs has almost disappeared and has gained a lot of ground on PVDF. So the difference in performance isn't quite what it used to be. And a lot of that has to do not only with the polymer technology that's being used, but the pigmentation as well. Used to be that in the polyesters, they didn't use, we talked about inorganic pigments and how good those are. They used to not use as much inorganic pigmentation in polyesters as they do now. Now everyone's kind of using the top of the line pigments in all three systems. So that leveled the playing field a little bit for performance. So again, these are just kind of general summaries, understanding that polyester has a lot more variability in it than the other two. And then we do see AMA specifications still being called out, and I've listed the ones here that are applicable to these three paint systems. And again, just kind of a rehash. Not all polyesters are the same, can't say it enough. The difference between the high-end polyesters and SMPs are marginal, if any difference at this point. PVDF still here in the US is the best system for UV resistance and optimal exterior durability. And then just a brief explanation, this Kynar 500 Hylar 5000 Kynar PVDF product, you actually have to use 70% of that resin. So the polymer backbone portion, 70% of that has to be PVDF. The other 30% is typically an acrylic resin, which is proprietary to each paint supplier. We do have some color and gloss limitations in the PVDF by the nature of it. The PVDF resin itself, before you add pigment to it, is kind of a milky white color. So you're not starting with a clear system like you are with SMPs and polys. You're starting with an already colored system, and then you have to try to pigment that white into whatever color you want it to be. And it can be hard to get high gloss, super high gloss in PVDF is a challenge. I'm going to stop there for any questions.
Thank you for that, all of that information. We do have more questions popping
Okay.
up. First is, what can you do to restore a metal roof whose color is chalking?
Yeah, so you can field paint if it's prepped right. And so you can come in and pressure wash it or sandblast it, get the old paint off, fix any corrosion that you have, and then you can field paint. Field paints are not going to come with the long-term performance and warranty that factory applied pre-painted does, but there's some really good air dry field paints available that'll have like a 10-year warranty if you go through the right supply chain and get it done. My caveat around field painting is you got to pick a contractor who really knows what they're doing and knows how to prep it properly. But you can go in and repaint. We see that at the end of their life, right? If they're faded really bad, it's a pretty common remedy that gets done.
Nice. It's good to know that repairs are an option, especially when they're done right. Another question that came up is, what is the expected lifespan between polyester and PVDF?
Good question. In general, I would say a good average polyester is going to give you maybe 20, 25 years of good performance without a lot of fade. A PVDF, we would expect to go 40 plus years. Now, that said, the new high-end, super durable polyesters that are slowly becoming available, there's not as much difference. Those are kind of 30, 35-year products. Maybe with a little, we're going to talk a little bit about what we mean by fade. There's a way to measure that. So even the high-end polyesters might fade a couple units more than the PVDF, but they're getting really close.
Okay, good to know. And then our last question is, oh, we've actually got a couple more. What paint would you recommend for areas that are subject to graffiti?
Yeah, it's a tough one. There are, we'll talk about it here on the enhancements a little bit. There are graffiti resistant coatings available that that not only is it hard to get graffiti to stick to them, they're then easier to clean up afterwards. And there's a couple of paint companies, suppliers that have those. Sometimes it involves applying a special clear coat over the color coat. Sometimes it doesn't. And then there's also some really good new cleaning products that have come out, which is really the bigger issue is cleaning the graffiti off afterwards. There's some really good products that are out there that are safe to use on these paint systems without taking away from their long-term performance. I won't talk about them now. You can reach out to me. There's 2 or 3 that we recommend that have been vetted against these paint systems and are safe to use. I'll clean that up.
Excellent. And then one more before we move on. Are there any specific paint systems that are better for certain applications, like agriculture versus commercial or residential?
In general, no. We tend to classify most light agricultural, commercial, and residential as kind of the same. You can use whichever paint system you want to go with. The difference there would be heavy industrial on the commercial side. So mining operations, chemical processing plants, anything where there's going to be exposure to maybe something really corrosive or detrimental to that paint, there needs to be a conversation around what the best paint system is. And the best paint system may not be one of these 3 I've just talked about. There's other paint systems available. Same with agricultural. Most agricultural environments, you can use PVDF or S&P or a good poly, that's fine. However, if it's a big like poultry farm operation or some of the big dairy operations that have a high level of corrosive animal waste occurring that these panels are going to be exposed to, you might want to choose something different. And the substrate underneath becomes important as well. You might be better off using galvanized for animal confinement instead of Galvalume. Next to the ocean, high salt content, you might be better off using aluminum instead of coated steel. So yeah, and we're going to get to it, but most of the warranties from the paint companies kind of spell out those parameters, what they consider heavy industrial, what is considered corrosive and what it's not. But I'd say for 90% of the commercial, ag, and residential, you can use any one of these 3 paints without problem.
Nice. Thanks so much. And without further ado, let's get back to the presentation and we'll answer further questions uh, at future opportunities.
So enhancements. So what do we need to consider when we just talked about a little bit, when you're picking your substrate in your paint system, right? If it's kind of a non-standard, unusual design or location. And these are the top ones, right? So proximity to salt water is a big one. Building energy, right? There's enhancements that metal can contribute to around that. Desired color and special aesthetics that you want. Reflection off the roof, both solar reflection and light reflection or glare off the roof. That's becoming important. How you use other materials with painted metal. You just need to do it right and correctly so that nothing gets compromised long term. Do you have exposed eaves? Do you have portions that are going to be sheltered from rainfall? And what does maintenance look like for that? So we'll dig into those a bit more. As far as special looks, we have micas and metallics. Those are your sparkly finishes, your silvers, your golds, your champagnes. Very popular for big architectural projects. Clear coats, we're going to talk about what clear coats bring to the table and when you might want to use those. Marine and industrial, graffiti resistant, someone was psychic. Cool cool pigmentation to keep things cooler, have better energy efficiency. Textures have become really big. We're really seeing a move to texturized paints. It gives you more of that depth of look and helps mimic other products like wood and stone better than just regular painted metal. And then prints and imagery, we will show examples. We can do imagery and print work through this pre-painted process. So again, micas and metallics are special pearlescent pigmentation that gives you this sparkle and shine. We see it mostly in cars, but we do use it in building products as well. Historically, we did this using actual metal flakes, like actual flakes of copper or aluminum. And that's why we use the term metallic. Now we use mica pigmentation, which are much more durable and don't need a clear coat over them. But in our world, we still use metallic as the main form, even though they're not true metallics. So you get that nice light catching effect. We can do color shift pigmentation as well. Again, you see that more in automotive, but where the color shifts depending on your viewing angle, you can do that for building products as well. It's the same pigmentation used in both. A little what not to do with the metallics and the micas, though, is they are directional and they are batch sensitive. This is the one type of paint we really can't control color consistency from batch to batch, run to run, because the nature of the pigment. So you need to run all your product for your project at once and not split it up. And then it's directional. So how it looks depends on the viewing angle and the direction in which it was painted. So these panels here that look off color are actually just 180 from the direction they were supposed to be. That's why they look different. And then this is the same. They actually reverse these panels, which is why they look darker than the ones around them. They're actually the same color, all run out of the same batch and out of the same coil. Extreme environment enhancements, again, marine, coastal's a big one here, and then industrial. There are paint systems and way to do this so you can still get a warranted product. It often involves using more primer and or a clear coat. So you're kind of beefing that paint system up to get more protection. And the warranties are not going to be the standard 40-year warranty. It's going to be more like 20 or 25, but still warrantable. Clear coats, again, help with graffiti resistance in some cases. They also can provide additional UV fade. So we talked about organic pigments a few minutes ago. If you want a really bright red or a bright blue or yellow that's mostly organic pigmentation, you can get that. You're going to need to put a clear coat over it to get any kind of long-term performance, get any type of warranty. Again, it'll be a limited warranty versus normal, but you can get a warranty. But you do need that clear coat on there. Clear coats can also help with perceived depth of the surface. They can help to build gloss up and get a shinier surface as well. And then there's clear coats out there that are approved for like food contact, that are resistive to food staining, and can add hardness and mar resistance as well. You see that more for interior applications. Do you need to talk about clears? They are clear. We call them clears. They actually have a slight yellow undertone to them. So when you apply them over a color, it might shift that base color a little bit. People need to just know that going in. It's usually very, very minor. Really only going to see it on your light colors. So the panels I have here left to right, the white and the red. On the left is just regular primer, regular top coat. And then we have a high build primer underneath, and then with a clear coat. And you can see on the light color that shift. It gets a little darker, a little bit more yellow, but on the red, it doesn't really do much. And this is just an awareness thing that while they're clears, they're not 100% clear. If they were 100% clear and translucent, they wouldn't be able to do their job, and you wouldn't get that extra UV protection out of them. Backers. We talked about the back side of the panel. There were some good questions earlier about that. We do paint it. We do that. But it's often overlooked and underappreciated because it's typically unseen. It's usually an off-white or a white. But again, we can do full coats on both sides. It is maintained, right? We do run it consistently, so it looks the same all the time because you might have an overhang or an eave. The inside of pre-engineered metal buildings, you may see that backside, so it needs to look good and look consistent. But yeah, most coaters can do double-sided paint as well with no issue. Cool colors, so cool pigmentation. These were introduced about 20 some odd years ago now. This is pigmentation that has been modified to reflect the infrared part of the spectrum, which is where you get heat buildup from. So we were able to keep the color of the pigment the same, the dark colors, but not get as hot. So basically we were able to create a black that stayed cooler in the sunlight and still looked black, which was kind of a game changer for our industry. Almost all of our standard paints now come with this type of pigmentation without having to ask for it. It's become the norm. Some of you might be familiar with the Cool Roof Rating Council out there that helps keep us all honest about what our performance attributes are and cool. The terminology can get a little confusing. We measure it a few different ways. Solar reflectance is the amount of solar radiation being reflected off that surface. We express it as a percentage or a decimal place number. And then there's emissivity, which means that's the amount of heat the surface can dissipate away from itself once it gets hot. You do a big, long, nasty calculation with those things and some other factors, and you get solar reflective index, SRI. This is what gets called out like in the LEED specification and the building codes is you need an SRI value of a certain amount for roofing. The Cool Roof Rating Council double checks us on all that, and then we do age results as well. I like to talk about the age results of our product because these products are formulated not to fade or change over time. They hold their initial SRI value very, very well. So you're not going to get any drop off in that energy efficiency performance over time with painted metal like you would with asphalt shingles or single membrane ply type coatings that degrade pretty quick. This one, the taupe, has an SRI of 53 when it's brand new. In 20 years, it's probably still going to have an SRI of 53. There's not going to be a drop off in performance. Again, here's the LEED. Some of you on this column are much more familiar with this than I am. You get the heat island reduction credit. Lighter colors are still going to have a higher SRI value than dark colors, and they do differentiate between low slope and steep slope. Low slope roofs at this point are pretty much limited to whites, but on the steep slope, you can still get colors that meet this criteria, so you have some design flexibility. Gloss and sheen. What does the visible shine off the surface look like? It gets a little confusing. We measure gloss two ways, at a 60-degree viewing angle and an 85-degree viewing angle. We call it sheen if it's at the 85-degree setting. Right. We've seen a real movement to low gloss, low sheen, a kind of a matte appearance for a couple of reasons. One, it looks better design-wise. Also, a lot of areas, counties, cities have put in their building codes limitations on the glare or the shine off of a roof for good reasons, right? No one wants to wake up and open your window in the morning and have your neighbor's roof blinding you with the sunlight that's shining off of it, right? So the movement to matte, low gloss, low sheen. That is different than the light reflectance value, right? Light reflectance value is kind of the color space that it's in, and that is independent from gloss and sheen. And all of those are independent from solar reflectance or solar SRI values. It gets a little confusing. We tried to we've got technical bulletins out there on this that, right, your LRV, your gloss, and your sheen are kind of independent to one another. Here's an example of that, of how we control this glare and get a low gloss, low sheen look. So these two panels here at the top, while it doesn't look it to the visual eye, numerically, these are the exact same color. space. Exactly. One's got low gloss, low sheen, and one doesn't. And that's the difference visually that occurs to the human eye. And we showed here the LRV is the same. Gloss vastly different, right? This one on the left only has a 0.9 gloss while we're up at 21 on the standard. Sheen, again, 3.8 versus 25, huge difference. But look, the solar reflective values are almost identical. So we can drop that gloss, drop that sheen, get that matte finish, and still have our high energy efficiency numbers that we need. Here's the printing, the imagery, which is really an exciting front right now in the pre-painted world. There's both ways to do this. We can do this what we call flexigraphically with our rollers that we saw earlier, our big rollers that we use on the line. We etch those or cut a pattern into those, then we layer colors to get the look we want. We're also now seeing digital printing capability on these continuously running lines. So you can do any kind of imagery you want that looks very photorealistic, which is very exciting, very cool. This is some of the imagery, right? So you can kind of print whatever you want. There's also laminates out there. We don't see laminates in the US as much. Asia uses a lot of laminates. Decorative imagery, again, that's printed onto a film, and then that film is adhered to the steel or the aluminum surface. Crazy imagery and designs you can do. Does not have nearly the same durability and long-term performance as the actual traditional pre-painted metal does. That film bond is not as strong. So we tend to see this a lot like on garage doors, column wraps, maybe interior applications, not so much on roofing and wall. But again, the digital printing, its durability and warrantability is getting very close to traditional paint systems. Not quite there yet, but it's getting there. And seeing much more of this come online in the US in the last 5 years. I'm going to stop real quick there for any questions.
Okay, so some questions have come in. Um, First one, are touch-up paints available and recommended?
They are available. Almost any good panel supplier is going to have touch-up paint that's been color matched to their standard color palette that you can get. As far as the recommendation, yes, with some caveats. And again, most of the suppliers have some really good technical bulletins on touch-up paint. If it's a very light scratch, and it doesn't go all the way through down to the substrate, and you can't see it from 3 feet back, you probably need to just leave it alone. Deeper scratches, just 1 or 2 here and there, lightly touch it up with the air dry touch-up paint. And the reason we say that is because it's not going to perform and fade the same as the rest of the panel. So over time, you'll be able to see that touch-up paint difference. So don't go in with a heavy hand. If you have a panel or a section that's heavily scratched, we recommend you replace the panels. So yeah, it's kind of a case-by-case basis. But yeah, any panel supplier is going to have touch-up paint available to send.
Okay, good to know. So it's a case-by-case basis.
Yeah.
And then another question, what is best for a coastal application? Is SMP paint, an SMP paint system good enough?
Typically, no. Some suppliers will warrant very limited, maybe between 5 and 10 years in S&P system next to the ocean. The recommendation is typically to go with a Kynar PVDF system, maybe with a high build primer, maybe with a clear coat. And when we talk about marine locations, it's important to talk about the whole system, including the substrate, because the substrate is going to play a much bigger role in the long-term performance than just the paint. So you're going to want a substrate. Best choice is aluminum. Next best choice is going to be galvalume. I would stay away from galvanized next to the coast. We're going to talk about it here a little bit in this next section, but the definition of marine setting is not consistent either between suppliers, and that presents some challenges. But there's different ways to get warrantability, but almost everyone right now is still recommending the PVDF along the coast.
Okay. And then one more question. What material is the clear coat and does it wear off down to the top coat? And if so, how stable is that top coat material, especially with concerns about rainwater harvesting?
A loaded question. The
Yes.
clear coat, we only do clear coats in PVDF. So it's PVDF color coat, PVDF clear coat. So like to like. So it's the same polymer, same technology as the color coat. It just doesn't have all the pigments in it. It will wear off first, right? It's the top of the system. It's exposed to the elements. So yes, it will start to fade, chalk and wear off, but it doesn't really wear off per se. Like it might chalk a little bit, but it's still on there. And when we're talking about, depending on environment, I mean, it may be 30, 40 years and there's still going to be clear coat on there. So this is not happening quickly at all. So it's quite stable. You got a lot of protection there. It's going to be there for a long time. As far as rainwater harvesting, that's always a tough question to answer. Um, yeah, the PVDF system, even with the clear, is going to be very inert in and of itself. It's not going to be leaching much, or not much is going to be coming out of that paint system for a very long time. That said, everyone's quality of the water that falls out of the sky is different depending on where you live, and that's more of a factor. It's what's in that rainwater, what's in the environment that's being deposited on that roof that's now going to be in the water coming off of it. It's hard. There's no blanket answer for that because of how different all of our environments and locations are, right? I mean, for existence, Hawaii, the big island of Hawaii, Hilo, and their active volcano, they have a tremendous amount of acid rain that's falling out of the sky around Hilo because of that volcano, like severely acidic. Is that going to wear down a roof paint system quicker than somewhere else? Yeah, it is. Would I want to collect water off of one of those roofs? Probably not. But it has nothing to do with the paint system. It's the environment.
Okay, great. Good to know. And with that, let's dive into the next section.
And last section. Hopefully everyone's still with us. So what are these paint warranties we've been talking about actually warrant, right? What are they saying this product's going to do? So there's the substrate. We talked about that early on, right? So some substrates like galvalume or zincalume come with a corrosion warranty component just on the metal itself. That's one. For paint, it's film integrity, chalk, and fade. And we'll get into what those mean and what the warranty parameters typically are. So its warranty periods are 5 years and up. The paint warranties are typically going to cover excessive chalking, excessive color fade, and delamination of the top coat or primer to the substrate. That's what we call film integrity. These failures can occur for a lot of reasons. It can be improper application by us, the coater. It can be due to something that went wrong during installation. It could be a bad paint formula from the paint supplier, bad quality control. It can be environmental conditions. This is an example here of a Japanese facility, coil coater, who wanted to do a real world experiment on their own building. So they put Kynar and acrylic and a polyester up and a silicone polyester up, starting all with the same color on the side of their building. And then many years later, every year they documented how it was looking. And you can see the Kynar still looks pretty much how it looked when it started. The acrylic is basically gone and is now white. The polyester has faded significantly. The S&P has faded some, but not as much as others. So kind of goes back to the traditional performance of the polyester, the Kynar, and the silicone polyester in the real world. Chalking is exactly what it sounds like. This is a white chalky substance that comes off the paint finish over time. This is due to degradation of the resin or the polymer system breaking down. Those can now come out because they've broken down into little tiny pieces and they're bringing pigment with them. Once that starts, then you get this color fade that occurs as well in this chalky substance. We don't see this very often anymore, especially in the high-end paint systems. It's fairly rare and it takes a long time to get to this level of chalking. The high-end paint systems, such as PVDFs, are going to be 20 years and up with little to no chalking. They're going to cover. They're going to say, look, after 20, 30 years, your chalk rating is going to be 8 or better. And for chalk, the higher the number, the better. There is an ASTM standard that measures this. 10 means there's absolutely no chalking at all. 8 means there's very, very little. So that's what the PVDF warranty is going to cover. An S&P or a high-end polyester warranty may say, we're going to guarantee chalking's better than 7, right? So it's still pretty good, but not quite as good as the PVDF. Color fade. This one's fairly self-explanatory. You know, UV attack on the pigment portion of the paint system. We measure it by a unit called delta E. That's how much that color has moved from where it started. The human eye starts to see a color change between 0.5 and 1 delta E. None of these warranties are ever going to say you're not going to have color fade. What they're saying is that in X amount of years, you will not have more than Y amount of color fade. So it's typically 5 units or 7 units, depending on the paint system. PVDFs almost always say, hey, in 30 years, you will not have more than 5 units of color fade over that time. So there's going to be fade. It's just going to be pretty small. And ideally, it's going to be consistent across all of the installations, so you kind of don't notice it. These are examples here. The standard, the starting colors on the top, 5 units in the middle, 7 units of change on the bottom. So yeah, it's going to move. But if it moves consistently and evenly, you know, no one's going to be the wiser. This is a roof here at the bottom. We get these calls. I've got striped panels. They're not performing the same. This can happen for a variety of reasons. It can be mismatched paint systems. Someone may have put an S&P along with a polyester on this roof, and now it's fading differentially. These faded panels may have been too low in film and are not holding up. That's possible as well. This could also be, and this is an important one, differences in paint supplier. Supplier A and supplier B are both providing an S&P paint to somebody. They're both S&P, but that doesn't mean they're going to perform exactly the same out in the field. So you never, ever want to mix paint suppliers on an installation. One supplier per job. Otherwise, you might get this. Delamination or loss of film integrity. This is a tough one out in the field because there's so many reasons why this might happen. But it's loss of the paint, the entire paint system to the substrate. It may be loss of adhesion between the top coat and the primer for some reason. It may present as bubbling of the paint. It may be peeling like this. Chipping, cracking can present a lot of different ways. The most common root causes for this are low film. So that's on us, the coater, for not having put enough paint on. The pre-treatment may not have been right. Maybe we didn't cure and dry the paint properly. And that's a fun one because if you under-cure the paint, it's going to do this. If you over-cure the paint, it's going to do this. We have a very tight window in between the two we have to hit. Could have been an incompatibility between the top coat and the primer that long-term is not holding up. But the one we probably see the most is mechanical damage. And by mechanical damage, we mean during installation, something scratched or damaged these painted panels. There's now an opening in the coating where water, moisture, other things can get in there and cause that paint system to kind of come apart. So if you look here on all of these, there's a distinct vertical line where this peeling is peeling away from on every single one. Most likely what happened on this roof is that they drug the corner of another panel across this one during installation. It created these scratches, and then over time, and this is, I think this roof had been installed for like 12 or 15 years. You get this peeling of paint away from that spot. I like to use the analogy on this, and this is not a claimable warranty failure. There is caveats in the warranties about, hey, if you damage it during installation, you don't install it right, you can't have a warranty claim. It's like our cars, right? You go and get a car, brand new car, it's got this beautiful paint job on it, and you know, I open my car door into a thorny, scratchy bush, and I scratch my paint system. I don't get to take it back and claim that the paint's bad, right? That was on me. So, and by the way, I didn't say it earlier. I always like to throw this out. Here's a little quiz. We're talking about these paints that go on the outside of buildings here and exposed to the elements for decades that have 30, 40, 50-year warranties. Anyone know what the average car warranty is on paint? Which, by the way, all has a clear coat and is applied at much thicker film than what we're talking about here. Most automotive paint warranties are only 7 to 10 years. With a lot more paint, a clear coat, car that's probably going to be in the garage or sheltered for a part of its life and is going to get routine washing and maintenance. And they're not willing to offer more than 10 years on those paint systems. So what we're talking about here for our world is a whole step up from that. Other failures that might occur that, and I know we're at 12 o'clock. I'm going to go quick. We talk about using other materials with painted metal. You do have to be careful about dissimilar metal situations. So certain metals in direct contact to each other in a corrosive environment are no good, and you're going to get premature corrosion failure. You got to make sure you're using the right sealants, that you pick up any metal filings when you're done doing install, because those can sit on the surface and rust and it looks bad. You got to store the product properly before installation so it doesn't corrode before you get it up on the roof. The picture I have here is, this is right next to the ocean in Southern California, like right on the surf break. This is a painted Galvalume roof with PVDF. They attach stainless steel gutters with stainless steel fasteners. So in a marine environment, the Galvalume is going to protect the stainless steel and is sacrificing itself to keep the stainless steel from corroding. So what happens is underneath where these clips and fasteners were, it's rusting through the panel. And this was only 7 years after installation. That's how quickly it can happen. So lots of guidelines out there around that as to how to avoid this and do installation properly, so that, this came in as a paint failure actually originally, and then when we got there, we realized there was something more going on than bad paint to some of metals. But unfortunate that happened. More dissimilar metals. Again, this is a stainless steel canister, lighting canister that was recessed through a Galvalume panel without a barrier, so they're in direct contact with each other. You get this ring of corrosion. It looks like the paint's failing. It's actually the substrate underneath is failing and being corroded away, and you get this paint failure as a result of that. Same house, by the way, here on the right is the one prior. They poured concrete right up to the metal panels without a water barrier between them. So the moisture from the concrete leaching into the metal panel and causing corrosion and failure. Paint system. So on the bottom here is treated wood. A lot of wood is treated with copper. Copper and painted Galvalume, painted galvanized product don't get along very well. So the water was leaching out of this deck up above, running down onto the panels below and causing corrosion. As soon as you got away from that deck, the panels were performing as expected. Swarf and metal filings. This is little pieces of, sometimes they have to cut panels on site and then you're drilling in, you get shavings, little metal shavings that come off and land on the surface, the painted surface. If you don't clean those up, they start to rust. And the call comes in as my paint system's failing. And it's like, no, that's something sitting on the surface that's rusting. Doesn't cause too many long-term performance issues, but it looks terrible. I mean, this one on the bottom is awful. And this is a brand new installation that looks like this. And once that stain is on there, that red rust stain is on there, it's almost impossible to get it off. Usually I have to come in and field paint or replace the panels. Wet stack storage. This is corrosion that can occur when the panels are stacked at a job site and there's moisture present, but they can't dry out. You start getting corrosion underneath the paint prematurely. Oil canning is an installation issue, not a paint or a substrate problem, but the buckling, right? You just can't lay flat or it can't expand and contract properly, so it starts to buckle. We recommend on long panels using styrations, these ribs in between, to minimize that look and effect. And using the right substrate as well. Important. So how do we avoid these failures, right? We want to use the right paint system for the application, a good coil coater, don't mix batches, don't mix suppliers. Understand the warranty you're getting ahead of time and what's being warranted and for how long. Store it right, install it right, have a good installer. Clean it. There are maintenance protocols. You do need to clean these roofs. They're easy. Metal's easy to clean. You just hose it down or brush it down. It's easy. But don't let dirt and debris pile up on it. That's going to cause issues long term as well. And the constructs of a coating warranty, do not read just the headline. The headline is always the film integrity, duration, and number. It's not the shock and fade. So you do have to read a few paragraphs in to see what's being covered. I know it's boring, but we recommend everyone do that. This is kind of what it'll look like. Again, we talked about locations and type of installations. They will spell that out. Like, so for this system in a regular environment, you're going to get 40 years. If you're in a severe marine environment, you got to put a little bit more paint on it, and you're going to get 15 years with the same paint system. So that will be spelled out in a warranty. Make sure you understand it. Again, the definition of marine, not consistent. My recommendation is if you are building a project within 1 mile of breaking surf, you need to have a conversation early on with your panel supplier and the paint supplier about what they're going to recommend for that location. Again, it's boring. You got to read it. They're usually only a page long, so it's not too bad. And we're at the end. I know we ran over, so I'm going to read this to you guys. We can do some questions.
Thank you so much, Michelle. And yes, we are a little over, but that's all right. We still have time for a couple of questions. And if we don't get to your questions, please, again, feel free to reach out to Steelscape. Um, so to start, wouldn't the coatings of the sheet metal be a barrier to dissimilar metal reactions? That's one question.
No. Well, yes, and they're designed to do that. So, yes, by intent. So the metallic coating, the zinc or the zinc and aluminum, are protecting the steel and iron underneath by design. Um, the issue we have is when you have a dissimilar metal situation between that metallic coating being in contact with something else like stainless. And again, the dissimilar metal, and I have a whole nother presentation. If you go to our website, I have a whole video on dissimilar metals. It gets into it more. It's only dissimilar metals is corrosion is only an issue in a corrosive environment. So if you're in a benign, normal environment, don't have to worry about it at all. Once you get like a mile back from the ocean, non-concern. So the vast majority of projects and installations don't have to worry about dissimilar metals. But if you're interested, you can reach out to me or you can go to our website and try to find that presentation that's a deeper, more specific overview of that process and concern.
Okay, great. And then last question, because we are out of time. Once the substrate coil is received in the at the coating facility, how long does it typically take to schedule it for coating, complete the coating process, and have it ready for shipment? Also, does the thickness and width of the coil affect the scheduling process?
Yeah, so that's going to vary by supplier and coater. Can't speak to that. Once the coil is ready for coating, I mean, can happen very quickly. Like you don't have to wait. Once you've applied the metallic coating, in theory, it can go straight to the paint line. Like it doesn't need to sit. Nothing needs to happen. It can go and get painted immediately. The width and thickness doesn't really impact. Now we do schedule by width because those the rolls that apply the paint are rubber and they do wear. So we schedule wide to narrow, and then we have to swap out those rolls. So yes, that could impact the schedule of the particular paint line that you're working with. We also schedule the lines to run by paint system because changing those paints out takes time and it's time consuming. So everyone likes to set up and run wide to narrow on the same paint supplier, get those orders done, and then change out to a new paint supplier, change your rolls and start over again. So we do block how we schedule the lines. But in theory, a coil could come right off the metallic coating line and go straight to the paint line and get painted immediately if desired.
Okay, well, thank you so much. That is all the time we have today. Please take note of the screen if you had any further questions. Thank you, Michelle, and thanks for
You.
everyone who joined.
Thanks, everyone. Have a great day.
Take care. Oh, and just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. As well, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks so much. Take care.